Hello, everyone.
Hi, Jonathan.
Hi, Mike.
Hey, man.
What's up?
Sitting back here drinking beer.
Christian took your spot.
That's where I used to sit.
Yeah. Okay, so welcome to December and our cozy winter turnout. Okay, so quick housekeeping stuff. We have a mailing list, a Google Plus community, a meetup group. You probably know about one of those things, which is why you're here now. So join the others. Pay for the stuff that you buy, because we don't have like a food sponsor, so you have to buy your own things. And they'll let us come back next month if you do. And then we also record all these things and post the videos at tjug.ca. So there was some Java news since last time we met. There's a performance analysis company called Plumber that's running a neat little puzzler contest right now. They're giving away 3 copies of the Java Puzzlers book to the people who submit a correct entry. Has anyone found this? They've been doing a whole social media thing for the past week or so. No, Christian did, and it's a great book. So worth entering. They've only had 100 correct entries so far, so you've got a pretty good chance of winning. It closes, I think, in about a week. So check it out. That's it. Christian has solved the shit out of it. So you can solve it, but the shit has already been taken out. So yeah, so check that out. Yeah. So Adapta.JSR is kind of cycling back up again. We participated as a Java user group in the previous cycle by playing with and commenting on the JSON's processing specification. I'll tell you afterwards how I feel about that, but I think if we get involved earlier this time, we could have more positive influence on the Java EE8 specs. So certainly anyone who's interested in playing with some like really early stage EE8 stuff, definitely do that. If you feel even a little bit like you might want to, you should do that. And we can come up with like a weeknight or weekend meetup where we play with the stuff. And this is a really good time to be submitting feedback. It was a bit late last time, and it was too late to get some of our feedback incorporated. But this is the perfect time for EE8. So definitely, if you plan to be using any Java app servers a year and a half from now, get involved. So there's a couple of links here you can check out with more information about the program, but definitely worth doing.
So what does it mean that TJUG actually adopted JSR?
Yeah, we met. What it actually meant was that the 4 people who actually could be bothered to get themselves out of bed on a Sunday morning met at the reference library and played with the JSON processing spec as it existed at the time, which was only about 4 months before final release. So they were only really taking feedback at that point on performance and serious API problems. And we had some use cases that we were concerned about, that it was honestly a bit too late to be addressed. But now is a great time. Like, the specs are just getting started. So now is a great time to be talking about how you would use it if it were to go final. And hopefully we can get more than 4 people interested this time, and we can submit basically a review of where it is now and point out some use cases that they might not have thought of in the expert group. Yeah. Yeah, we'll post a list of the JSRs that are up for discussion right now to the list and see what everyone's interested in. Yeah, that the link down here, the top one, that's a meeting that's happening tomorrow. Everyone is welcome to get on the phone call. There's information about the phone-in number, but that's basically just as kickoff discussion about it. And if you follow that link, you'll see a list of all the JSRs that are currently open. A lot of them have just started. So coming up in Java 8 Update 40 is a giant improvement in JavaScript performance. So if you're running JavaScript workloads in your JRE, this will be a big boost for you, especially if you're doing any kind of numeric work. There's a picture here of basically what they did was that looks terrible. What they did was they rewrote the code generation parts. So the part that takes the AST and produces bytecode, they've completely redone that for Java 8 Update 40. And the red lines are sort of the normalized, what it used to be before Java 8 Update 40 in Nashorn. The blue lines are what the Mozilla Rhino interpreter did. And the green lines are what you're going to get after Update 40. Basically, all the benchmarks that involve numeric computation are orders of magnitude bigger. So I shouldn't say orders, order of magnitude bigger. So no, it's not logarithmic. So yeah, if you're running any JavaScript on your server, this update will help you a lot. Brian Getz did a new talk. We've been tracking him at Java 1 for the past 3 years, and he's been giving the same talk since 3 years ago. So he's a very interesting and dynamic speaker, and I haven't watched this yet, but it's on my holiday break watching list. I think it will be really interesting. He's basically talking about the difficulties of making changes to a language that's now more than 15 years old without breaking anything. And I'm really interested to see what he says about it, because he is a really interesting speaker. And is it like a new thing that he's talking about? He's been talking about lambdas in JDK 8 for the last 3 years, and basically nothing else. So this is from the mailbag. Mark Reinhold, who runs the whole Java project at Oracle, posted to the mailing list a couple days ago that the first step of Jigsaw has now been merged into the master branch of JDK 9. Most importantly is probably this part about rt.jar, tools.jar, and dt.jar have been removed from Java. So you have to use the new module system now to get access to the contents of what used to be in those jars for the last 15 years. So this will probably break a lot of stuff up front, but it's all designed to use the new module system. It's going to be great in the long run. I think it will break a whole bunch of things in the short run.
So if you have a batch job or something that puts this stuff in a class path, what is it module? How do you invoke these classes?
The class path still exists after this update, but the different components of the JRE are not just jars on the class path anymore. They're proper modules as defined by the new module specification for JDK 9.
There's an API to invoke those?
Yep, there's a new URI scheme. It's that next point on the list. There's a new URI scheme in NIO for accessing stored modules. And you can't yet make your own. These are just the built-in ones that you can access using that mechanism. But hopefully by the time Java 9 is released, you'll be able to create your own modules and access them in the same way. So you can still get access to scanning those jars, but they don't have those names anymore, and you have to access them in a special way because they're modules. And of course, we miss stuff every month. Does anybody have other news that we haven't covered?
Sony got hacked.
Sony got hacked.
I don't know if they leaked any Java code.
That's news. Okay, so now the feature presentation. Arun Malay, who invites you all to address him as the Iron Male.
All right, my name's Oren, and in my spare time I'm a game developer, and I use Java at work, so I've started using Java to make games. And I'm going to take you along my journey of kind of all my mistakes that I made while making games with Java until I finally found something that worked. So what you're going to learn today is a little bit about Java and gaming and why not too many people make games in Java, but it's getting more popular. Some general architecture of making a simple game, so a nice high-level view. Some of the concepts we're going to talk about are the game loop, time steps, then we're going to go dive into some code, and then switch over to OpenGL with my favorite tool, the lightweight Java gaming library. So pretty much now Java is actually getting more popular for games, especially with Android that's beefing up more Java coders getting into the industry. Pretty much the only reason why it hasn't been as big as it is because C++ took over early when Java was really slow, and it just had a better rep, so they started making better tools for it. When people were making bigger and better games, they started to invest in these tools. The game industry is pretty strict, so you don't want to waste time or money when you don't have to. So when you can grab a nice C++ game engine or physics engine, most companies are going to do it. But now that's changing. Java's a lot faster. It's just-in-time compiler, can keep up with C++ speeds, so that whole argument is now out the door. Popular new engines like the Unity engine take advantage of C#, which also has a garbage collector. So even though the console argument for not using Java on consoles can't maintain a 60 frame per second frame rate because garbage collector will kick in and pause you every now and then and stuff like that, it's starting to not be such an issue these days. Plus we have a lot more powerful machines with way more memory. But right now, not all games are perfect for Java. Games that do require a very strict frame rate, like fighting games, where if you screw up on the frame rate, people's combos will mess up, and anything that's really competitive is not going to be good for Java right now unless you really invest in a pauseless garbage collector or a whole lot of optimization. Also, if you need to make a game that's going to have a really complex game engine or have like really complex physics, there's just too many good tools right now that you can use that are in C++. But we're making waves. Hold on, I can make this smaller. What I see on my laptop's a little different. There we go. All right, so the first concept I want to talk about is the game loop. And all games pretty much have a game loop no matter what game you're trying to make, and they all follow the same thing. First, you set up your resources when the game starts, and then you go through this loop where you get inputs, update your game states and all the objects, and then render everything. So it doesn't matter what you're getting inputs from. It's just you're going to follow this order. And for our first simple game, we're going to start with 60 frame per second. So we're going to have a 16 millisecond wait on our game loop, and we're just going to keep it hard-coded like that. So pretty much a game is a model. You're building a world, you're setting up rules for it, and then everything that lives in this world, that interacts in this world, is a game object. So that could be like a player, an enemy, an item, bullets, the background, walls, doesn't matter, they're all game objects. So how we're going to set up this game is that all of these game objects, players, are all going to extend an abstract class called GameObject that's going to provide our common features and utilities like collision, drawing, updating, having a position, having health, having damage, just to keep everything simple. Then in our main game loop, we don't need to know if it's a player or an enemy. We can just call these general functions and run them on everything.
Can I ask you a quick question?
Yeah.
You say abstract early interface, but how much implementation can you put in something when every game is going to be fairly different, imagine, right? How much commonality is there really?
So pretty much every game is going to have collision, drawing, rendering, and then position.
So why not an interface for those things? How can you implement something so
Well, with an interface now, every single class you have is going to have to implement them differently, but there's going to be so much overlap. Like, especially collision, you're pretty, most say everything as like a rectangle collision. You don't want to implement that for like, your 20 different enemies.
It's like physics behavior.
Exactly. Or even drawing, like say, especially when you start out, everything you're just going to draw, simple rectangle, you're in prototype mode, that can just be implemented in one spot. You can have in your abstract class a whole bunch of other helper draw methods that you re-implement and call separately in the separate class, but at least you have that there. Also, you can make final methods where you're like, you know what? I don't want anyone to be able to change this because this will break things down the road, or I'm actually using like a variable from somewhere else and I want to make sure no one misses it. So like it's just something that I learned is kind of a helper when working through. Every now and then there comes a time where I'm like, you know what? My game object, my general game object that I designed, it does not fit this certain scenario. Fine, it gets its own class. But just to keep things a little bit more simple. And in the main game loop, which I'll show later, it's just nice to have like game object be the general class for almost everything, so that we're not constantly like checking what class type or anything like that. All right, so we're gonna make a game. And the game I wanna make is gonna be a shoot 'em up, and that's like top down, you're an airplane, you can shoot, there's tons of enemies, you're moving up, the enemies are moving down, instant conflict, we got ourselves a game. So we're gonna build that. So the basic things you need, and I'm starting from the bare bones that I started when I first learned how to make games in Java. You need a window, so for that we're gonna use swing and get a J-frame. We're gonna add a J-panel to it, and our game loop is pretty much gonna be an action listener on our J-panel. That's gonna have a timer, and we're gonna make that be 16 milliseconds. Now we have a game loop, and then a keyboard listener to get some inputs. Nice, simple game. All right, let me go into my IDE. Okay. All right, so the main high-level class is game. And game's a J-frame, and pretty much all it does is it initializes our screen and how we want our window to look, and then adds on our game loop class, and that's gonna cover the loop. So I'm just doing simple things, undecorating it, setting the screen size. I've hard-coded a size here that is actually now what full screen is because I had to make my resolution smaller. So let's change that on the fly so we got something smaller. So that doesn't break everything, we'll see how I coded this. So then what happens is once we've added our game loop, because our game loop class is a JPanel that also is attached to an action listener, this timer right here is going to start kicking off our action preferred method. So this is acting as our game loop. It gets our inputs, updates, and then renders. Now, before I dive into that, I'm getting inputs using a key listener. And what happens is those inputs are coming in whenever I get those events. And a proper game loop, you kind of don't want to take the chance of changing state or altering code when you're in the middle of updating your objects or you're in the middle of drawing, because it's going to cause like small problems, especially if your engine gets a little complicated. So what I'm actually doing is I'm making a judgment call based on what I want to get done. If I want to move the player, I'm not going to do that on key press. I'm going to flag that for later so that when I run my get inputs, it knows to update for that frame to move them. But for instance, if I want to make the player shoot, that method is going to happen. If they tap it twice in one frame, good for them. They get 2 shots. So it's just a judgment call on what you want done, just to like keep that game feel solid. So if a player's working extra hard, he feels like he's getting something extra. And I'll go into the player class where we can see where that's done. It's simple. So when I call get input, I'm really just updating the player's inputs, and that just goes and checks what keys were pressed. They've been set. So whenever a key event comes, I just flag that move up was pressed. If a release comes, I flag that it was released. And then in the update, only once per frame, do I actually let the player move? And player speeds are hard-coded. You just fiddle around with a number you like till you get something that feels good. Then calling update. Update is kind of going through it goes through my logic, but really all my logic is in my game objects. So it just loops through all my game objects. I could have put all of these in the same array list all together. It wouldn't matter, but that becomes a problem later because I don't want to search through a giant array list when I actually want to pick out just enemies for something or just backgrounds for something. So right now I separated them. There's not too many, so it hasn't started an issue. Then we call collision. I have simple collision where I just loop through all my objects and I say, if shots hit an enemy, call this method. If enemies hit a player, call this method. Nice and simple, and that's happening as part of update. Remove is what I do at the end, where I'm just saying if anything has life that's too low, remove it. Nice and simple. And then last is render. So for graphics 2D, Java has its own graphics class that you can get using swings render method. So what's happening is this paint method is being called by me in my render, but also Java AWT has a link with the operating system, which is also giving like render calls like it would to my operating system's normal window. So sometimes you'll notice that you'll call render and something else might happen in update first because your operating system is kind of optimizing when its render happens versus the render you called. So there is some stuff happening in the background, which we'll have to fix eventually.
Your method is single threaded, right? Is that a programming convenience or there's a reason for that? Like you can't
yep.
stars before background is over and so on.
Yep, so what's happening is it's almost like I'm separating my layers by just saying the order. So I want my background to be first, then on top of that, my stars are drawn, then on top of that, enemies are drawn, then on top of that, the player, then on top of that, shots. So it's just like simple way to just layer it. There are times when you're like, I want only these backgrounds to be on top of those, and then you have to have another design pattern or algorithm strategy to get that. But I don't need to this time. And then I'm just drawing out my frames per second. I just simply literally let it run, count how long a second is, and see how many frames I hit. This is the best way to get it accurate without it flipping nonstop like 60 times a second. So that's our simple game. At the beginning, I'm creating all my arrays for everything I need, enemies, shots, stars. I've got an image loader that is just simply a list of all my image files I want, and I just call them by their names because I made this demo in 2 days. And it just loads in bitmap image, buffered images and displays them using my graphics calls. So like for instance, inside player, I just choose which plane I want to animate. If I'm turning left, I choose the left plane. If I'm turning left even more, I choose to turn more left plane. And like very, very simple. More complex animation requires a small little state machine, but we don't need that for this one. So anyway, let's give it a run and see if it works. And I'm just using Maven, makes a jar, and runs it. All right, so we got our game. It's running at 60 frames. Oh, wow, yeah. Well, my computer doesn't. OK, so here's our game. So I'm pressing the shoot key. The movement's fine. I'm chopping just because my laptop's my laptop. But we did it, yo. We made a game. And it's awesome. All right. Yo, so let's get paid. All right, so yeah. Guys, so we released this game, and just wait for the money to roll in. We end up checking our email, and all we get is a ton of emails of people saying, man, Oren, I paid so much money for this game, but it's lagging so bad. I'm playing on my Comedy 64. It's lagging all over the place. So you go back and you're like, oh, fine, I'm going to fix it. So this is what's happening. They got to level 2, and level 2 looks like this. And you know, that's not too bad. Like, they're playing, and then they got to level 3, and level 3 plays like this. And now it doesn't even feel like it's your computer's fault. It really feels like the game is slow. That's level 5, and well, yeah. So no, level 5. So all right, fine. It's the game's fault. We're gonna go fix it. So now we got to go and fix it. We don't want them to cheat and have it too easy because it's going so slow. So pretty much what's happening is we hard-coded our 60 frames per second, and what happens is if it takes longer than 16 milliseconds to go through that frame, we're still only moving our 6.5 pixels or whatever we set it to. So that needs to be changed. We need to actually start tracing how long each frame is and multiplying all of our speeds by that multiple to actually make sure that within a second, no matter how many frames we get, we're always going to be moving the same speed, the same distance. And what happens is even though it'll be lagging and it'll still be looking like choppy, the game's going to feel the same. It's not going to speed up or slow down based on how fast their computer's running. So it's not going to be our fault. It's going to be their fault. And getting that feel, they're not going to email us. They're going to go buy a new computer. So now what we're going to do is, because we're tracking that time, we no longer need to have 16 milliseconds wait on our loop. We're just going to loop as fast as we want, and the game's going to just take care of it. So for an example of how we're going to do that, oh man, I can't see what I'm saying. Okay, whatever. Is in our game loop, our update is now going to have a delta time. And that's going to be the time right now for the time of the last one. And we'll just track it right here. All right. Equals right now minus last time. And if we want that in seconds, because it's really nice to have time in seconds when you're actually trying to decide. If you have a game object that's like, I want the speed to be 200 pixels times my time step, and you don't really know what the ratio is. If you know it's in seconds, you're like, I'm moving 200 pixels per second. So divide that by 1,000, and now we have seconds. So now this is going to go into our update. It's going to filter through all of our game objects. Each game object is going to have, all of the times where it's movement. Anytime it has speed is going to be multiplied by that delta time. And we have to do that for everything. So we'll go on to the next demo where it's all done. Because who wants to wait? It might be dangerous to have two open in this computer. All right. So let's take a look at our game loop. Now what we're doing is we grab delta time. I moved it into a method where it just does the same thing, grabs our last time and returns the difference. And I filter that through. Everything gets updated. If you look at our enemies, boom. So that's happening to every game object. So now, no matter how fast it runs or slow it runs, it's always going to move the same distance over time. Let's run that and see how it goes. Oh yeah, of course it boots up on the other side. 1 second. Let's give me something to hold on to. All right, so here's our game. And the backgrounds are random because I just stole them from the internet. So here's our game, works fine. You notice now our frames per second, it's running as fast as it can. But it doesn't matter, the game still runs at the same speed. If they beat level 1, let's bring them to level 2. All right, now we're still moving at the same speed. I'll take I'll put them back to level 1 real quick. Just to see like our speed. So we're still going the same speed no matter what. If we really push it, yeah, we're still moving the same speed. It looks a little choppy, but that's the computer's fault. So we did it. All right, no more emails. Okay, we did it. We made a game. So now we have a time step. Oh yeah. So we're done. Let's make that money. So we release our game, wait for that check to come in, end up checking our emails, and we just get a ton of people saying, man, Oren, paid money for this thing. How come it's running in this little box? I want to be able to full screen. That's our fault. All right, so now we got to go, and we got to make sure that we handle that. So first thing that always comes to my mind is screw it. I'll just find whatever resolution the screen is and make my game that size. When I first instantiate all my images, I'll grow them by whatever that factor is, but that gets too complicated because now when you're moving, all your speeds, which are also a multiple of your time step, delta time, now need to be a multiple of your screen size, because if your screen size is bigger and you want your plane to move from the full left to the full right, it's going to take longer if they have a bigger monitor. So all of those pretty much come down to we got to take everything we're drawing and scale it. And when we start doing things like this is where I started to realize that the regular Java way of doing it without any special libraries is kind of not fast enough. When you start adding transparency, when you start adding like lighting and all of that stuff, Java just starts to chug a little bit. And especially when you want to make a game where you don't want to go to your game designer or your artist and say, yeah, I can't do that, I'm sorry, it lags. Like, that's the worst. Like, we're supposed to be able to build things around that. So here's an example of full screen. Actually, you know what? I'll keep both of these on. All right, full screen mode equals true. So pretty much what I'm doing is I'm finding out what I have to multiply everything to. So the best part is I'm designing my game for this screen resolution, which just so happens to be the one that's on this projector. But let's say it's smaller. And the best part about that is now when I design my game, all my little tweaks, I'm using this resolution to tweak with. Then, so if the resolution was something that was dynamic, I can never really judge how I want a game to feel. How fast do I want something to move? How big do I want something to like appear? If I want any dynamic growth or anything like that, it gets too messy. So you just pick a resolution you like, stick with it. If you have an artist that does pixel animation, stretching those things really ruins pixel because it has to be like 1 by 1 no matter what. So like those things, it's nice to have a resolution you can stick with, and then you find out what you want your scale to be. So I'm just finding what full screen is, dividing that over what my normal resolution I'm designing with is, and I get my full screen multiplier, which turns into like 1 point something. And then simply, when I render everything in my game loop,
Are you saying you're going to scale your bitmaps or your images as well?
so what I'm doing is all of my bitmaps, images, everything, I'm drawing that into my graphics object.
Right.
And then I'm scaling the one graphics object. So it's like first I have my small screen and I just take that and scale it once. That way I don't have to actually go through and mess with all those little things. Like it's actually better optimized if right away I could take all of those images and scale them once and then just use them because they're already in memory. But what happens is then I can't use dynamic stuff. I can't have like an algorithm that's building me some image in my code, because then that whole thing needs to have that extra level of complexity to it. If I have something that like explodes and grows as it grows, that all of those equations have to have that added, and it just becomes a big mess. So the downside is this is slower. So all I'm doing is right at the beginning before I draw, I'm scaling, I draw everything, and then when it turns into my full screen, it's exactly the size I need. Anyway, let's give this a run and see what it's like. Actually, you know what? Hold on. Let's make the screen smaller so it actually has to scale something. Oh no, if I full screen, it only shows up on my laptop. Maybe if I full screen first and then mirror, we'll try how that works. That might work, that might work. What do you mean my dock? Like this?
Yeah.
Oh. But then maybe it won't load, right? Because it doesn't like the resolution? Okay. Yeah. All right, let's see how this works. Okay, I just mirrored it. All right, so this is in full screen, and if you'll notice, it's cutting me off, I guess, because it doesn't like the full resolution of my laptop. But before we were getting about 300 frames. This is the exact same code, but with the scale, we're getting only 170. So already that's making like a solid difference, just having that one, and I'm doing it once per frame. So they get to level 2, and it's just gonna get to the point where it's too inefficient. Welcome, Adib. So, oh man, you should see my actual games. Oh buddy, this is nothing. You just gotta press shoot a lot. You should see my, I'll show you later. So pretty much, once we add rotations that we're doing dynamically, certain objects might scale dynamically, we might have lighting effects, we might have transparency. Java just chugs, it just can't do it. And that's pretty much when I realized that I gotta find something else. So yeah, so pretty much those are the things that are slowing me down. So before we get into the lightweight Java gaming library, Java in 1.6, and actually before a lot of these things existed, but they just got a nice beef up, is using OpenGL on its own with a lot of the features that have already existed, because they started to realize, hey, the community is kind of getting behind this and starting to make games or doing some graphic stuff with Java now, and it makes sense to have these features. So one cool technique is double buffering. Whenever our operating system is drawing to the screen, we're also drawing to that. We're writing to it, and the OS is reading from it. So double buffering kind of removes the bottleneck of writing and reading at the same time, causing a problem. We draw everything to one image, but we have the screen read from another one in memory. And then when we're ready, with page flipping, we just switch the pointer, so now the one that's fully drawn, we don't need to write to it anymore. It grabs that for that frame. And then we start writing to the next image. Or double buffering, we just start copying that one image once over, that's only one write, and then it can read from it, and we start drawing on the other one again, and when that's ready, we copy it once over. So that will help speed up Java too. Full screen exclusive mode is pretty much telling our operating system, listen, don't draw ever. All of the render calls are gonna come from my game, so I don't need like extra things, any extra memory or any extra rendering coming from the operating system. My game's gonna be full screen, and I'm gonna be the one telling it exactly what to draw. Then also a lot of cool 2D methods that Java has, like doing scale, doing transparency. Under the right circumstances, it is calling OpenGL to accelerate those features. Now, it's not giving us control to mess with OpenGL ourselves. It's all doing it under the hood and giving us like a wrapper around that stuff. So you kind of like only in certain like bitmap modes are you allowed to have transparency use OpenGL. Otherwise, it's going to fall back on its old slow way. So it kind of got a little complicated trying to get Java to play with doing the exact things I wanted to do. The other thing, display modes, is like getting our driver information. Before, C was so good at getting all that low-level hardware info, but now Java has a nice way, especially for like your color depth and everything else, to actually be able to match your drivers so it doesn't have to do that on the fly. So anyway, after all these, I found out that I was still having problems, stuff that I wanted to do I really couldn't do without it actually lagging me up a little bit. So I started looking for a tool, and that's where I found the lightweight Java gaming library. So the lightweight Java gaming library is pretty much native API for OpenGL. Very little, and for sound and for parallel computing, but I haven't, that's beyond the scope of this talk. So the best part about it is that you can pretty much take, oh wow. So pretty much this is C rendering code this is the Java. Like, you can pretty much copy and paste all those great OpenGL Nihi tutorials or like Doom source code and just paste it into your game. All the cool techniques, all the optimization, like OpenGL's been around since like 1992, like all that knowledge we can take advantage of because we no longer have Java's wrapper that doesn't let us play with it. We are just full access to the native API. A cool thing about the lightweight Java gaming library is that it provides with Maven nice little build configs to say, here's all the DLLs you'll need for Mac, Windows, Linux. We're already going to load them in exactly the place you need. When you make your build and like launch4j it into exe, here's like the one command you need to access those jars. They're always in those DLLs, and now you have like full support Mac, Windows, Linux to get that full OpenGL optimization. So it does a lot of cool things, but really it's not more than native APIs. There's cool tools built on top of it to handle all this stuff if you don't want to write that, like invent the wheel code again, but that's half the fun. So let's look at the same game, but now using lightweight Java gaming library. And just close some of these unnecessary windows. Actually, let's keep full screen on. We'll do a comparison later. All right, so now here's our game. You notice, no more swing. Get out of here. I'll make this smaller just so that we can force it to full screen. Pretty much everything at the top that I defined is exactly the same. So now what we have is we're actually initializing OpenGL the same way that you would initialize it if you were using C++. So we find out all of our optimized full screen things that we need, and the display is really the lightweight Java gaming wrapper around the GL init display. It just like gives us a simple way to not have to write that boilerplate, but that's really all that lightweight Java gaming library does outside of just simple native stuff. So initialize our display and create it just like we would with OpenGL. I'm turning vsync off right now because vsync is going to map us to 60 frames per second like we had it when we were fixed, and we don't need that right now. Let's just let it roar and see how fast we can go. Then this is the exact initializing of like a normal 2D window that I'll need. And these blend techniques just let me have text. The one thing OpenGL doesn't do all too well is text. Most people like back in the day would do a cheat where like if you'd zoom up to text in a game like Doom, it would get all pixelated because really it's an image that they just pasted in because text isn't done well. So for that, there's a little tool that OpenGL uses that's built on top, that lightweight Java gaming library uses that's built on top of it. That's called Slick, and that handles things like doing our sound a little bit easier, doing text, and a few of the other things that every game needs, but we don't want to code from scratch. So and also a good thing is that our game loop code is now simply in a while. No more timer to worry about. That timer is totally not accurate, the swing one anyway. No action listener to worry about. It's just a simple while loop that does the same thing. Gets all our inputs, does our update, does our render. Here I'm just drawing out my frames per second so we can see them on the screen, and updates our display. And whenever I hit exit, it quits out, it destroys the display, and the game ends. So if we jump into our update, update's exactly the same. Didn't have to change anything. All that I did was I started rewriting my render code. And because all of those drawing calls were pretty much in an abstract class, to change everything and make everything render the way we want, I just go into my game object class and I rewrote this. So instead of it saying like graphics2d.drawImage, I do it the OpenGL way. And now everything that's going to draw in player whenever I want to render, right here. Hold on, draw. There we go. I'm just calling that one draw image with a position that's in, that's in our game object class. So pretty much all I had to do was initialize my screen and really just add in the Maven dependency, initialize my screen with OpenGL, change all my rendering calls to use OpenGL. Oh, and also how I load in textures, I can't use buffered images. I actually need a real texture. So that's where Slick comes in. It's like a simple tool that just does texture loading the same way you would load in any file and pops out a texture for me. So Slick has a few of those little handy things that just comes hand in hand with the lightweight Java gaming library, just so that I don't have to dive in and like figure out how I'm going to map the bit array to whatever I need. All right. Oops. Let's not open up GIMP. Ah, come on. I got to do this fast or else it's going to load forever. All right, we got lucky. All right, so let's see if this one will render with this weird config. Maybe, because I'm mirrored right now, I might get lucky. All right, so it's, well, all right, here we go. So look at those frames, and we're in full screen mode. So,
500 frames a second.
yep, so pretty much what's happening is before I think we got 300 when we didn't full screen, and then 150 when we did, and now we get 550 when we are full screening. And, you know, let's go to level 2. All right, we've got 12,000 enemy objects. And like collisions being run on these too, so I'm looping through all this stuff multiplied by all the shots that are in the screen. And we're still hitting like, you know, this is playable. You can play with 45. I've done it. All right, let's go to 20,000 and see what frames we get.
Isn't 640 enemies enough for anyone?
Oh man, I got a game for you to play. All right, so we're getting like, let's say 30. We're getting 30.
40K enemies though. Oh yeah.
Yeah, there you go, there you go.
That's true.
So we're getting about 30 frames per second with 20,000 using lightweight Java gaming library. Let's quickly switch back to the old one. Oh, I can't do it like that. And let's see what we get with 20K. All right, if this doesn't work, then I'll just swap my monitors quick. Oh, it worked! All right, level 2. All right, so it looks like.
I'm giving you a 1-star review until you increase the frame rate.
Oh yeah. All right, so it looks like we are getting like 7. So that's like what, 20? Anyway, that's a huge percent from like 22 to 30. That's solid improvement. I know people who like companies spend like millions of dollars getting 2%, 1%. So pretty much like that's when now, and the other thing is, really all we're doing is scale. Scale is what I'm using to judge performance. But when I have lighting happening and rotations happening on the fly, then that percent, that difference is huge, especially with lighting, because Java doesn't handle lighting very well at all. It pretty much just thinks everything is like a different level of opacity, and it's not pretty. Another thing that OpenGL does great is like we can actually draw pixels. So like save an enemy who explodes, you can say like draw that explosion pixels on other textures and have that save in memory so that they look like they've been hit and they'll always look like they've been hit, which is really cool. And that won't slow down either. All right, so yo, we did it. All right, we made a game with OpenGL. It's smooth, it's fast, it's performant. So now we're gonna release, right? We're gonna release, wait for that money to come in. We just made a whole game. You're gonna check our email and everyone's gonna come and say, you know what? On my Commodore 64 playing your game, when I shoot, sometimes my bullets are going through enemies. And what's happening for that is that we have a problem with our time step. So how our time step is originally is that we just count how long has it been since the next frame. If it's been like 10 minutes, fine, that object's gonna move 2,000 pixels because that's how long it's been. But because we're only checking collision every frame, that 2,000 pixels, that bullet's gonna be before an enemy and after an enemy. It's never going to actually overlap. Collision's never going to kick in. If this was Mario, we'd fall through the wall. Actually, there are games where the bug is that people say, brand new games, yo, my guy fell through the wall. I'm like, yeah, because it lagged out. It had a game spike. Your console did an update out of the blue, stole all of it, paused it for like a full second, and that guy moved too far. So the fix that I use, because I'm like, listen, I'm not getting too complicated into this, is that I have a maximum frame step. And if you hit it, no matter what, tough, your computer slows down. And we go back to where we were when we were fixed, when if it lags, you slow down. So I'm like, you know what? Once you hit 25 frames per second, if you go any lower than that, I'm just gonna slow the whole game down so that I can guarantee you're not gonna move before and after an object and collision will miss. But there are smarter ways. One is where we detach our render loop and our update loop. So it's like, say, our game's running really slow, 10 frames per second. What we're gonna do is, oh, okay, no, let's not say that. Let's say we're running at 60 frames per second, but our computer's fast enough. Now, we might have like an engine, a complex physics engine that it's like, listen, unless you can give me a time step that's fully accurate, that's always the same, we can't guarantee that you're gonna get the exact physics you want. And you're working on like a simulation game and you can't have mistakes, like NASA called you. So what you're gonna do is you're gonna fix your time step, say it's 5 milliseconds, and you're going to loop over just update and get input multiple times until you're ready to render. Then you'll render. So you're actually getting multiple calls of update. Your render is still stuck to 60, and really you don't need more than 60. That's what your monitor is gonna have anyway, so you're not wasting resources like we are rendering 500 frames per second. And that's like one way to get out of having a time step that you can't control. Now, a problem with that is if you are lagging and your computer is slow, you might not be able to get that many loops out without causing a problem. And that's where like you get the conundrum of why no game engine this day is perfect. There's always going to be that give and take of where you're going to slow down or you're going to have these inaccuracies with your time step. So pretty much that was my adventure that I went on making Java games. I started with Swing, and I thought it was awesome. And then I realized that no one likes my games because they're too slow. I fixed my time step, I did all the tricks I can, got Java 1.6, played with all of its updates, and I realized that when I really try to push a game and make a large game with 20,000 enemies because I don't want you to win, Java just can't handle it. So switching over to OpenGL, which is what my current game is running in right now, is where I can really get that feeling where I can push it, I get my performance. I just use my maximum allowed time step technique because there's no need to worry about having like a fancy update loop that's running multiple times. I don't have a physics engine that's going to mess with anything really. But yeah, that's like, 5 months of how to make games in 40 minutes. Anyway, that's my talk. This is my game Hardline Gunner that I'm working on. It's the hardest game ever. I actually had to make the AI stupid because people are getting too frustrated. But see all those pretty lighting techniques? Yeah, OpenGL. Oh, and this, okay, let's see if it'll, this laptop lags. My desktop is better, but I should have, oh, I don't even know if it's in working order. No, it's called Hardline Gunner. That's just my, when I first started, I didn't know what I was going to make. I just was at work and someone's like, yo, have you looked at Maven? You don't have to use Ant anymore. And I'm like, oh, now I got to go home and mess with Maven. And I ended up making like a little square that moves around and it kind of turned into this game. And then when the game got fun, I realized, oh, now I have to make it. I can't just let it go. So, yeah. Let's see if it boots up.
Maybe you covered this already, but what's this render loop like compared to the JSF render loop?
Oh, like. I didn't do my homework, Adib.
You don't need to make a server request every time there's a frame. I see you're logging your errors.
All right, it seems to work. Pardon?
I see you're logging your errors, your track as well. But do you have a strategy for exception handling in the game? Because I don't know games at all.
Pretty much, this is what I do. I make sure at the very top level of my update loop that I can continue with the next frame if I get an exception. Because if the game's gonna break, it's gonna break anyway, but when you're writing your own render, like your own collision detection and your own simple engine, you're gonna have weird little errors that are gonna kick in for one frame. Because like just something, and you know what? There's no point in having like the player's experience be ruined by stopping the game. So like if it's gonna break anyway. Now I just let it run every single time and break every single time, then it really broke. And that's probably just on like a game feel point of view. I think like that, even though it's kind of bad, that's just how I've been handling it.
For business systems, but for games, I can see.
Yeah. It's like, if, you know, there's so many broken games that we've all learned to love and play. I'm not going to take that away from you. All right, so this is my game. So we have to play the first level. I forgot I implemented all this stuff. Oh, and I need a mouse. Okay, so you're this dude, and the game's simple. There's no like upgrades or level ups or anything. All you can do is you can move, you can shoot, and you can spin. And what spinning does is, oh man, does someone have a mouse?
You can really shoot.
So, oh yeah, you can gun it. So pretty much like if an enemy is gonna, oh shit, I forgot this level sucks. Oh no. My bad, this was testing. Okay, hold on. Oh, it's gonna be on YouTube? Oh, I don't even remember. Wait. All right, cheat mode. No, that's not how we do. Okay, skip level. All right, I think level 2 makes more sense. All right, so we got some enemies. Beautiful, eh? Yeah, that's my artist right over there who set up all of that. All right, so here's a secret. Look at that. Oh, you wouldn't even know it's there. All right, so this is a spread shot. So here's my normal gun. And then how this game's designed is whenever you get a bonus, you can only get one, like in Mario Kart. Once you get a shell, you can't get it something else. And the second you activate it, you have it for only 10 seconds. So let's not waste it. Let's find some enemies to smoke with it, like now.
So that's just 5 months you did that?
Pardon?
Just 5 months you did all that?
This is maybe like 8 months in. All right, so anyway, let's get out of here. So we just beat that level. Let's see what level 15 is. I forgot how crazy these got. Oh, here's a boss. This guy has no mercy. Oh wait, there's an item there. I need to get that. Oh, spread, yeah.
Careful, there's bad things.
Oh yeah, so whenever your life gets too low, it goes in slow motion because it just feels so good. Oh, no, I'm gonna get him. No, he's going down. Don't worry. Oh, I need a mouse. I'm on touchpad, guys. Okay, let's see what gun I get now. Oh, rocket this time. All right, I just gotta make sure I deke everything. Okay, so I can deflect these back at him if I time my spin. But I have touchpad, so I gotta do it with 2 fingers, and it's like, oh. Those green ones, they like me, so they're gonna follow. There, I just absorbed them with spin. Oh, take that. Oh, no. Oh, shit. Oh, no one's got a mouse? Oh. All right, okay, hold on. Let's just go to another level. Let's see what level 3's got for us. Level 3's got these little guys that like to shoot at me. Oh, there's a lot of them. Screw them, man. Let's get out of here. Oh, wait, hold on. I just saw a secret door. Health. That's going to come in handy. Oh, get out of here. Oh, so when I'm spinning, that blue bar below my health, that is, I'm invincible. Because this game, you need to, oh, there we go. Spread.
Oh, that's great.
All right. Yeah, so this was a game that, like, pretty much, with all this stuff happening, like, how ridiculous this gets, it forced me to have to look for OpenGL. It's just Java couldn't, oh, and the thing is, these aren't textures. I'm actually drawing lines for everything on the fly. So that's how I can get the walls to do this, because it's not an actual image. Like, as I move left and right, the walls are pretending that they're in 3D. It's really just like a simple projection.
this to Android?
So the best part about this is Android's already in Java, and to do a port to Android, all you need to do is two things. One is use their drawing API, which is pretty much all in my game object class. So I just go through the one class everything uses and all my helper functions I made, I rewrite with them with the drawing API for Android. The other thing I do is go for the input API, which is just my key event, and I rewrite that to use Android's like touch controls or whatever I want to set up. There's actually tons of like libraries that automatically do it and give you like a controller on screen and stuff like that. So it's like the engine stays the same, the logic stays the same. Oh, and actually no, you really got to watch memory on Android. Like I'm really just taking advantage of being able to be like, I want 1,000,000 bullets. But the port is actually quite easy. Another good thing of having OpenGL is that if you say I want to make this, man, I want to make it WebGL and put it in JavaScript, you got to do the change of syntax from Java to JavaScript, which really isn't too bad. But then all that GL for WebGL uses OpenGL API. Like all that code is already in WebGL because you're using the lightweight Java gaming library. Because you're already low level enough that you don't really need to. So that's like render port done, just syntax. There might even be like a tool that you just pump Java and get JavaScript. You just made a WebGL game. So like very, very convenient. All right, guys, thanks so much. This was my first talk ever, so I'd love to have your feedback over a beer. I was terrified for this, but it actually was super fun.